Mm, 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 mm. Eric Darling here with Darling Data. As you'd well expect by at this point, if you're surprised by any of this, I don't know what's wrong with you. You maybe you should start taking notes about your day. You might have some sort of head knock that is plaguing you in some way. I would suggest getting that checked out by a medical professional as well. At this point, I feel like this is a well-established set of facts. I am Eric Darling, and my company is Darling Data, and we talk about SQL Server. That is our goal. That is our row goal. In today's video, we are going to talk about indexing for performance with unpredictable searches. You can consider an unpredictable search as anything that generates a query. Intel. Anything that generates a query that you don't know what the where clause is going to be, or maybe you don't know what the joins sometimes are going to be, or what columns are going to select, or something like that. It could be dynamic SQL in a stored procedure. Or it could be some ad hoc query generated by a front-end dashboard type thing that you have created, hopefully in a sober and thoughtful way. But that is what an unpredictable search is for me. You have no idea what users are going to ask for, or maybe even what quantity they're going to ask for it in. There are all sorts of crazy things that you have to account for. But of course, before we talk about how you can account for that, we must talk about other accounting matters, more like my accounting matters. We're being honest here. If you would like to support the content that I create on this channel, somewhere in near or around this channel, for the low price of $4 a month, you can click the little video description in the video description. Click the link in the video description. There we go. That's the right chain of words, and you can become a member. $4 a month. That's about $3.10 for me after YouTube takes out taxes. If you are just too encumbered by other debts and ransoms, and your money is already allocated fully to other endeavors, you can like, you can comment, you can subscribe. There are all sorts of things you can do to let me know that you love me and would die for me. If you look at the things that I talk about on this channel, and the first thing you think is, gosh darn it, that Eric Darling sure can make SQL Server faster in exchange for money, perhaps I could do one of these things for you, because I'm very helpful when it comes to these things. And not only am I helpful, but my rates are reasonable. And while we're on the subject of reasonable, gosh darn it, have you ever wanted to get 24 hours of SQL Server performance tuning training for $150 and not have to pay another $150 every year for the rest of your natural life? You can do that with my training. It's amazing. You click on that link, you enter that discount code, and kaboom, you have what I just described. It's pretty wonderful. Mouse. No upcoming events, 2025, blah, blah, blah. We'll talk about that later. But now let's talk about this indexing conundrum that we have. First, I'm going to close Event Viewer. I was troubleshooting a blue screen earlier. I know that. Do my talents end anywhere? Yes. Pretty much where the computer ends. It's the limitation right there. Where the computer stops. No idea what I'm doing outside of that. It's funny how that works. So we're going to talk about one of my favorite things. I'm going to move some of this text down a little bit there so it fits on the screen better. One of my favorite things that I help clients with are big, ugly queries. I know, weird that a performance tuner likes big, ugly queries. Suppose it's a lot easier to take a big, ugly query and chop out all the easy stuff and make it go faster than to take what looks like a perfect query and tune that better. But, you know, some people just don't know what they're doing in either case. So that's why people like me exist. So one of the most common things that I see people start with looks something like this. What you see, my head is mildly infringing upon. Where someone will have a parameter or whatever called search string. And that search string will be used to double wildcard search every column in a table. This is one of the worst possible things you can do if you need to handle unpredictable searches in SQL Server. I beg you not to do this. This will end up terribly. You may look at some of the columns in this list, like owner user ID and creation date and last activity date, and think, Eric, I don't think those are strings. And I would say, well, you are right, but you're searching them like strings, and all hell's going to break loose. It's not going to be a good time for you or your SQL Server. You really shouldn't be doing anything that even looks like this. The problem is somewhat obvious if you've been using SQL Server for long enough. Double wildcard searches and searching columns with mismatching types will lead to not only big scans because of the double wildcard, but also you're going to be dealing with implicit conversions. Everything, the title column actually is a nvarchar 250 or something column. So that would at least not result in an implicit conversion right there, but the rest of them you are hosed on. It's going to be a bad time. What you might think is that using something like some of the built-in functions in SQL Server might be more highly performative. Not performant, we don't say that word in this channel. I might beep that out later if I can figure out how to beep things out. You might think that it might be more performative. There might be more performativeness if you use car index or pad index, but generally there is not. There are some edge cases where I've seen them like do somewhat better, but it's not really worth talking about. But the problem in like the way that you deal with null parameters, if you use like isNull or coalesce or anything like that, it's not a more clever scenario than doing something like this. Both of these end up with the exact same problems unless you use a statement level recompile on your query, right? Something like that. If you do this, you can get around most of the issues that come out with these unpredictable searches. Most of the time, this will be Mr. Fix-It for you, right? This will do okay. And for a lot of people, this is the path of least resistance, and this is the simplest thing to do because the alternative is writing a lot of dynamic SQL to cope with which parameters actually need to be part of the where clause. I'm going to show you an example of just using recompile, it being nice and easy, and as long as you're not allergic to compiling a query plan every time a thing runs, whether it's because you are burned out on CPU anyway. If you have CPU slack and you're able to compile queries whenever you want, this is a perfectly fine thing, as long as that like the compile time for that query is not awful. Every time you run this query with a recompile, it runs for a long time, but the time isn't like in the query plan. You might want to check the compilation time to make sure SQL Server isn't going off on one of its little like thought cloud staring things. So there is that. Now, the problem with developers is that they are often quite lazy in the database. They often think that they are far more clever than they are when it comes to doing things in the database. SQL Server is an expensive piece of equipment, but people treat it just kind of like a garbage dump for like their worst code. The recompile advice is generally good enough, but when you use it again, just pay attention to compile times. There's like if it's like a few hundred milliseconds, screw it. But like if it's getting up into like 5-10 seconds of compile time, you might have to think about alternate ways of doing this. SQL Server right now doesn't offer any great programmability or optimizer support for the types of queries I'm talking about. However, it was a thing that came up in the SQL Server 2025 release notes that there is a new optimizer feature called Oppo, which is the optional parameter problem orifice, or I forget what the other PO is for. The optional parameter problem or something. So it looks like Microsoft is taking some steps to try to address this in SQL Server 2025. Sooner or later you will probably see that in Azure SQL DB. And if Microsoft ever decides that it cares about managed instance again, you might even see it come to managed instance. Microsoft's track record with getting things cloud first has not been awesome lately. There are signs that there may be a return to that ethos, but who knows? It's a bit weird. But anyway, sometimes writing good queries does require extra typing and thinking, and that's often not what developers are famous for. You want to start throwing weird features at it, like hekaton and memory stuff. You feel like you need to partition your table when you don't. You want to move to Postgres because you swear Postgres will just do better at everything. You've heard it's this magical unicorn and everything's better there. Or you want to start using NoSQL, or stick it all in Elasticsearch or MongoDB or whatever. Or you decide that maybe you just need to build your own ORM. Right? Just start from scratch. It's 18 to 24 months of work, far more interesting than 5 to 10 minutes of typing some extra characters into SSMS. If we have this query and like a store procedure, let's say, maybe this gets a little more convenient to show this here than like a dumb front end that I would make badly anyway, and we stick a recompile hint at the end of this thing, this will do okay. Without the recompile hint, this will go really, really poorly. You might notice that the time over here at the end is 6 minutes and 17 seconds. That is a very long query. A lot of that is because of a bad memory estimate where the sort does take an additional like 6 minutes and 3 seconds, because when we get up to this filter operator, we're at 13 seconds, which still isn't great, right? We can see very clearly that we spent a lot of time in other places in the query leading up to that 6-minute ordeal, but the main problem is without the recompile hint, the predicates in your search, and this doesn't matter, again, if you use isnull, coalesce, whatever other clever arrangement you think you've found that makes the optimizer do smarter stuff, that predicate is always going to look something like this. This is because SQL Server has to cache a plan that's safe for any outcome of these parameters being null or not. The recompile hint gets around this by allowing for something called a parameter embedding optimization, which allows SQL Server to take the parameter values and use them in the query as literals. So it doesn't have to cache a plan that's safe for anything. It can just say, hey, there's a plan for these values. This is as good as I can do, which may not always be great either, but that depends on a lot of other things like indexes and whatnot. So you should really avoid this sort of thing without the benefit of the option recompile hint, because it will go quite poorly. If we do use option recompile with this store procedure, things will go generally okay. Now, the thing that I run into a lot is that with store procedures like this, there's usually a value that people think users will always search on. And they'll design an index or two that makes sense for those types of queries. But then as soon as you depart from that, as soon as that one value isn't involved, things get really, really bad. That's especially true without the recompile hint, because you cache a plan and SQL Server reuses it, and that you might have used the entirely wrong index for that query. For our purposes and for the intent of the query, let's pretend that we think we're always going to be searching on owner user ID, and we know that we're always going to be ordering by score descending. That's exactly what our query does up here. We have an equality predicate on owner user ID, and we have an order by score descending. This does get a little bit more complicated if you have dynamic sorting allowed as well, but we'll talk a little more about that when we get somewhat further down. So we can design an index that looks like this, that takes care of our immediate equality search and our ordering, right? So we can search to whatever user IDs we care about, and we have the score descending column in order based on that equality search, and then we can put any secondary search columns over here. Now, I've done that for the date columns. These are going to be residual predicates. You cannot seek to these because the score column is in the way. Again, we'll talk about that a little more in a moment. But since post type ID is an incredibly unselective, it's a very dense column, I have stuck that in the includes because it doesn't matter so much in this case. So I already have this index created, I believe. I mean, I should anyway. Yes, I do. Good, we got an error there. I'm smart. So if I go and run these two queries with where I do use owner user ID, like the plans that I get from these are perfectly fine, right? We get 2 seeks. SQL Server does okay enough cardinality estimation from these. No one is upset or hurting from this. And where this query, so like what the parameters that I used for the very slow plan up here, these were actually the creation date and last activity date parameters that you see in here, these things. So that's what I passed in to get this slow query without the option recompile. With option recompile, SQL Server makes a much better choice overall, just chooses to scan the clustered index, doesn't choose to reuse a plan, gets close enough to, okay cardinality estimate, and this thing finishing in under a second without a good supporting index, totally reasonable. Now, where things get tricky, of course, is that when you start writing queries like this that are unpredictable, you have no idea what set of indexes to roll out because you have no idea what are going to be the most common set of search criteria that people pass in. And it takes kind of a lot of sort of like logging and analytics to figure out what the most common search things are and if they're slow or not, and then how to index for them. And you can end up with a lot of different permutations of sort of a similar index definition when you go down that route. Now, this is a pretty simple thing because we're just hitting one table, right? We're only hitting the post table, and we have all sorts of search parameters against that. So, but if we were to think about this for a query that might touch more than one table, you might be dealing with more than one search element, and things might get really tricky because now you have to think about indexing multiple queries and taking into account join keys and stuff like that. There's all sorts of things that get really, really tough and complicated with this. Now, if you don't have the ability to, or rather, let's say, much like the $4 a month that you could use to become a member of this channel, let's say you can't afford to recompile this query every time. The way to get around that is to write dynamic SQL, the safe parameterized kind that avoids SQL injection and has equivalent plan reuse functionality to any other store procedure that you would run, because we execute the query using SP execute SQL, which is a store procedure, and you get the type of parameterization and plan reuse and all that other good stuff that you would find in other cases. But you would use that to build a sort of a custom where clause based on what parameters apply to the particular search that you're running. So if we recreate this with all that in mind, jumped around on me a little bit there. These things will all still be okay. Right? We're going to get, pretty much equivalent performance to what we saw with the recompile. We get the 2 seeks here with the, we do reuse this plan, so the cardinality estimate is reused, right? We can see that there is plan reuse with this. So this guessed 1 of 82, and this is 5,000 of 82. So the guess of 82, rather the cardinality estimate of 82 rows persisted there. And that also lives on with this, that if we executed more than one variation of this, we would reuse the estimates for that plan, right? So no big deal here. But again, coming back to what's difficult with these things is knowing how often they run. Query store is pretty helpful for this sort of thing because, well, if you're smart and when you write dynamic SQL, you put in a comment with the procedure name that something comes from, you can use my free store procedure, SP Quickie Store, to search query text for this type of token, and you can find all the queries that run and see how many executions they have, which is a very useful thing. So the problem with Rowstore indexes is that the order that the keys are defined in defines how queries can access stuff. Now, there are clients who I've been working with for years, and I've been talking about indexing for years, and they're still unclear on the fact that if you have an index like this that leads with owner user ID, that is not the same as if you have an index where owner user ID is like the second or third or fourth or fifth key column in the index. Like by that point, you have lost any useful sorting for searching stuff. Multi-column indexes really are only useful for either things that search for the leading key column or things that search for the leading key column and then other stuff, right? Or for ordering and other things. But if we're thinking about just being where clause centric here, this is really when Rowstore indexes, multi-key Rowstore indexes are very useful because you can seek to owner user ID, and then you can seek to score or order by score, and then you could seek to creation date or last activity date or post type ID or ID. You can seek across all the keys, but you have to start seeking with that first key column. Otherwise, it's just a scan of everything because there's no helpful. It's not ordered in a helpful way after that. So for example, like with our other query where we need to search on these 2 columns, we're not accessing these 2 columns first via where clauses or anything. So everything is all out of sorts for those searches. That's why we end up scanning the clustered index. So what you generally want to do is if you can, and there are lots of considerations for this, and this is, we've already kind of gotten to the 20-minute mark here, and some of you may feel dissatisfied that I have not gone into all of the potential things that might come up by using column store, but it's sort of generally creating a non-clustered column store index, right? And just because it doesn't say non-clustered in here doesn't mean it's not. I can't create a clustered index on the post table. It already has I can't create a clustered column store index on the post table because it already has a clustered row store index. So it is creating a non-clustered column store index. So in general, if you create a clustered column store index that spans the columns you care about searching in your query, things will end up a lot better, and the unpredictability doesn't matter as much. The reason it doesn't matter as much is because column store indexes don't have that column-to-column dependency that Rowstore indexes do. Each one of these columns is stored in its own little vertical up and down columnar index within the column store index, and there's like lots of little mini indexes sort of on like all the different segments and row groups. So you can pick and choose which columns you want to hit. So if you want to hit owner user ID and creation date, or you want to hit score and last activity date, it doesn't make any difference to the column store index what order you search for things in or anything like that, because each one of these columns has independence from any other column that might precede it in the key of the index, unlike Rowstore indexes. So you can make all of your search queries, you can give all of your search queries a single, good, highly compressed, very nice place to search for data from without having all the problems that of creating multiple non-clustered Rowstore indexes in order to try to satisfy every different permutation of a search. So the way that I love to handle this sort of thing for clients, and as long as the shoe fits with using column store in their database, I think my biggest consideration is if we're relying on query parallelism to make things fast and you're on standard edition, we need to really carefully test the column store thing, because Microsoft hates people on standard edition, and it limits all of the column store parallelism to a DOP of 2. You cannot exceed a DOP of 2. So if you have a query that runs really fast at DOP 8 using Rowstore indexes and standard edition, and you start using column store index, and you're like, wait a minute, my queries got slower even though I'm using batch mode in the column store index. Well, it's because your query is limited to a DOP of 2, and you can't do nothing about that. So the way that me, Eric Darling, with Darling Data, likes to handle unpredictable searches by using column store is typically a lot easier and more efficient than creating like 17 different Rowstore indexes to account for everything that someone might search for. So we're going to wrap this one up here. Thank you for watching. I hope you enjoyed yourselves. I hope you learned something, and I hope that you will continue watching. I forget what the next video is about, but it probably, hopefully won't be as long as this one, because the tongue does get tired. And there's a wise man who once said, the reason dogs have so many friends is because they wag their tails, not their tongues. I guess that explains why I spend so much time alone. Anyway, thank you for watching.